Yeah, very good morning, all. So today I would like to uh, take you the lecture of artificial intelligence and expert systems. Okay, so this is a part of the course of expert systems for second year BTech of SITRC in the open elective. Okay, for the year of 2025 and 26. So basically, we have to first know what is meant by artificial intelligence. See, human being are all living creatures is inbuilt having some type of intelligence. Intelligence is just it is the ability to sense and sense the situation and respond accordingly. So, as a human beings, we are equipped with inbuilt intelligence. But whenever we want to design some type of machine or some system, if it is assigned with some type of intelligence, okay, artificially, that is known as a artificial intelligence. The artificial intelligence concept arises in the computer science engineering. Okay, it is concerned with the symbolic reasoning and problem solving. Artificial intelligence has many definitions. So, most of them are behavior by a machine that, if performed by a human being, would be considered as intelligent. Okay, so we are making the machine to be intelligent. So, it is also can be described as a study of how to make computers do things at which the at moment the people are better. Theory of how human mind works. In simple words, artificial intelligence is the intelligence possessed by the or intelligence exhibited by the machine or system, computer system, according to the given problem. Okay, next, artificial intelligence main objectives are to make the machines smarter, that is primary goal. Second is the understand what intelligence is, and third one is make machines more intelligent and useful. And signs of intelligence are learn or understand from experience. If the machine is experiencing but from basic learning or understanding from experience, then it may be a sign of intelligence. Make machine out of ambiguous situations. Respond quickly to new situations. Use reasoning to solve problems. All these things will be categorized as a signs of intelligence. Okay. So Alan Turing is one of the scientists. He had done one test to know whenever we are communicating over a computer, we should aware that we don't know the other person is a computer or an expert which is communicating. For example, if you are making a chart with the chart box, okay, chart bot. So in that case, the person who is the communicator who is outside is either may not be a human being. Simply the computer is just responding. That is a chatbot is a program. Whereas if you want to speak to any customer care or customer service executive over a chat, then the other person at the system is a human being. So the test was basically earlier conducted by this Alan Turing, in that a computer can be considered to be smart only when the human interviewer are conversing with both an unseen human being and an unseen computer cannot determine which is which. So this theory is first proposed by Alan Turing. Okay, he had done one experiment on the computer, and from that experiment, he had concluded that we cannot exactly know the other person outside the other side who is communicating is either a machine or human being. There are two possibilities. Next is AI represent knowledge as a symbols and uses these symbols to represent problems and apply various strategies and tools to manipulate symbols to solve problems. A symbol is a string of characters that stands for some real world concept. Okay, that is example product or consumer, etc. AI concepts. See, in the AI concepts, the reasoning, pattern matching, and knowledge base, these things are playing major role. For example, if you are designing a computer system or expert system, in that expert system, the knowledge base and inference capability are must, and the inputs are given and outputs will be obtained. So the reasoning is it is inferencing from the facts and rules using heuristics or other search approaches. And pattern matching is attempt to describe a major object, events or process in terms of their qualitative features and logical and computational relationships. Knowledge base. Knowledge base is nothing but whatever the knowledge that is required for the problem solving will be kept here in the knowledge base. Okay. So next is evolution of artificial intelligence. The evolution of artificial intelligence tracks long back to the 1960s, where a Navy solutions were developed. Next, general methods were developed, and domain knowledge is developed, and hybrid solutions were developed, and in recently 2000, embedded applications were resulting. Okay, so at the recent nowadays, that is in 2010s and 2020s, the machine learning and that artificial intelligence is playing a major significant role. Okay, so this is just complexity of the solutions is gradually increasing decade by decade. So consider the two cases, artificial intelligence and natural intelligence. The artificial intelligence is having some advantages. For example, it is more permanent in nature, ease of duplication and dissemination, less expensive, consistent and thorough, can be documented, can execute certain tasks much faster, can perform certain tasks better than many people. But the if we compare the artificial intelligence with the human being, that is biological natural intelligence, biological natural intelligence is truly creative. It can use sensory input directly and creatively, can apply experience in different situations. And these are the applications. Just the AI can be used in linguistics. Linguistic means language related concepts, psychology, philosophy, computer science, electrical engineering, mechanics, hydraulics, physics, optometry, and management and organization theory, chemistry. Okay. Next, physics, statistics, mathematics. Next, computer hardware and software, commercial, government, and military organizations. So, a very vast amount of applications were developed. See, consider this picture. This picture is taken from the Pearson Education and PHI, Prentice Hall, India. So here, if you consider one tree, the tree is having a both roots as well as branches. So the roots here, if we assume that this tree is of AI tree, that is artificial intelligence, is compared with this tree. In that tree, we are having a different roots. The uh, f- roots are forming so many aspects, that is disciplines. Okay, like linguistics, biology, robotics, computer engineering. Next, pattern recognition, neurology, human being. All these are roots of the AI. Whereas applications will be actually the video games or game playing, automatic programming, speech understanding. Today we are, for example, in the Google, if we just say some few words, then automatically results, so many results will be fetching. So that is speech understanding application, intelligent tutoring, intelligent agents. Intelligent tutoring means it is, uh, for example, assignment based online courses and voice recognition. Okay, neural networks, genetic algorithms, fuzzy logic, machine learning. All these forms applications of the AI. Okay, this is the best comparison. Next, and one more, the robotics, autonomous robots. Autonomous robots is the best example for the this artificial intelligence application. Next, coming to the expert system. Expert system is a computer program that attempts to intimate or imitate experts' reasoning processes and knowledge in solving specific problems. So, expert system, as the name itself, it is expert in solving a particular problem. Okay. So, most popular applied AI technology. It is the most popular applied AI technology. Enhance productivity, augment workforces, works best with narrow problem or area tasks. Expert systems do not replace experts, but make their knowledge and experience more widely available. Thus, permit non-experts to work better. Next, expert. Expert is a human being who has developed a high level of proficiency in making judgments in a specific domain. So expertise. Expertise is the knowledge and the skill sets processed by the expert, okay, including extensive domain knowledge, heuristic rules, meta knowledge, and metacognition, compiled forms of behavior, etc. Okay, and coming to the important concept of expert systems. So expert systems will be dealing with the experts, transferring experts, inferencing, like that. So, for example, if we are having a certain situation, so how we need to decide our actions, that is based upon the if then rules. The knowledge is generally represented as a if then rules, and if then rules having a some type of explanation capability, that is why this rule is to be used, how this rule is to be used, etc. Okay, and transferring expertise from the expert to the computer nano experts, non-experts via acquisition, representation, inference, transfer. And after that inferencing is nothing but it is knowledge, gaps, facts, procedures, etc. And in the expert system development, some systems will be appearing as a milestones like dendrol, mycin, xcon, etc. So these are the former one of the significant systems developed in the expert system development. Dendrol. Dendrol is it is applied knowledge. It deals with the applied knowledge and deduced likely molecular structure of the components. Mycin, a rule-based expert system used for diagnosing and treating bacterial infections. XCON, a rule-based expert system. It is used to determine the optimal information systems configuration. And coming to the new applications, there are so many new applications: credit analysis, marketing, finance, manufacturing, human resources, etc. Okay. So coming to the structure of expert systems, this diagram will better will give you the knowledge about the structure. See here, consider this diagram once. Just observe it properly. If we see, the inference engine is the key and major part of the expert system. This inference system will make use of knowledge in the form of a inference rules. Okay, the knowledge is fed into the inference rules by means of a human experts. Okay, human experts, other knowledge sources, all these will be contributing to the knowledge through the knowledge engineer. Okay, next, the user who is ultimate, the beneficiary who is operating the expert system. Okay, for that purpose the user is provided with some type of user interface. For example, if I'm using a computer system, my user interface is keyboard and this microphone, etc. That is your and a display device. So like that, some interface to be applied. And the by taking these inputs, the inference expert system will solve it with the help of working memory, external data sources, knowledge based terms, all these. And it will solve the problem, again return back to the user the solved problem via user interface. So this can be total system can be divided into two parts. One is consultation environment, another one is the development environment. In the development environment, the human experts, knowledge experts, and other knowledge sources or inference engine, all this will come into picture. And coming to the consultation environment, user interface, working memory, all this will be coming like this. Okay. So generally you need to remember this particular diagram as a part of expert system. See, this is also the same as the previous one, but a little bit it is modified. See here, human expert and information available already will be fed into the knowledge engineer. The knowledge engineer will develop the control structure for inference engine, and he also proposes structured knowledge for the knowledge base. And the expert system will make use of this working memory, inference engine, and knowledge base will solve the problem for the user interface user. Okay. So sometimes it is associated with the external interface also. Just if you understand this particular logic diagrams, then you can able to explain. So the human element in expert systems are expert, knowledge engineer, next user, like other system analyst, builder, support staff, etc. Okay. So this is today's class.